In the previous lesson, we turned unknowns into an information gap table. We now know which questions remain unanswered, but an investigation cannot always stop at more information is needed. A decision maker may still need a current judgment. Two weak responses are common. One is, I think the risk is high. The other is, this company will definitely fail. The first has no scale. The second turns an estimate into a fact. This lesson introduces probability language. We will connect the probability of an event, our confidence in the analysis, the evidence base, the decision threshold, and the conditions that would change the judgment.
Some questions can be verified as true or false. A screenshot either came from a specific official account or it did not. Many intelligence questions are different. Will delivery pressure rise in the next 6 months? Do two accounts belong to the same operating team? Does an executive departure signal a strategic shift? Public evidence may support one explanation without excluding every alternative. Old image reuse is a useful example. We may confirm with high confidence that a photograph is 2 years old, while still being unable to identify the first person who used it deceptively. Different claims inside one case can carry different judgment strengths.
Probability terms are not decorative caution. They are a team communication tool. If one analyst uses likely to mean 60% and another uses it to mean 90%, a decision maker cannot compare their work. A shared lexicon reduces that wording gap and lets the team record movement from unlikely to likely when evidence changes. The term still needs an event, evidence, and limitations. During review, ask whether the reader could mistake likely for already happened. If so, make the event and time horizon clearer rather than adding more probability words. The scale on this slide is an example, not a universal standard. A team might define very unlikely as roughly 5 to 20%, unlikely as 20 to 40, roughly even chance as 40 to 60, likely as 60 to 80, and very likely as 80 to 95. Boundaries may overlap because intelligence analysis is not a thermometer reading. Publish the lexicon in the project method or team guide, then calibrate it. If events labeled very likely occur only half the time, the team is systematically overconfident and should adjust its language. Percentages can create a false impression of precision. Most OSINT cases do not contain enough structured data to justify an exact number. If the evidence consists of announcements, hiring changes, and court records, writing 73.2% does not make the analysis scientific. It creates pseudo-precision. A defensible range is better when the analyst can explain why support, counter-evidence, and gaps place the judgment there. Base rates change the situation. If the team has reliable historical data on similar suppliers, that data can anchor the estimate. If we have only a handful of clues about one company, the judgment is primarily structured analysis, not statistical prediction. This is the central distinction in the lesson. The event is likely, and we have high confidence, do not mean the same thing. Event probability asks how likely significant delivery pressure is during the next 6 months. Analytic confidence asks how much trust we place in that estimate. Several risk signals may push probability upward, while missing customer data and dependent sources keep confidence moderate or low. The reverse is possible too. Strong independent evidence may support a high confidence judgment that an event is unlikely. Think of a weather forecast. Rain probability concerns the event. Model agreement and data quality concern the confidence foundation. Confidence does not measure how firmly the analyst speaks. It measures the analytical foundation. Look at source reliability, proximity to the original fact, genuine independence, consistency, and the treatment of counter-evidence. Ask whether the largest gap could overturn the conclusion. Then check whether another analyst can reproduce the reasoning and compare the same alternatives. Low confidence does not make a judgment useless. It warns the reader not to treat the estimate as stable and tells collectors where more evidence would matter. Honest, low confidence is more useful than false certainty. Do not start by choosing a probability term. First, define the event completely: who, what, and by when. Then list supporting evidence, counter-evidence,
and plausible alternatives. Review the historical baseline or comparable cases. Mark the most decision-relevant gap. Only then select a probability range and assess confidence separately. Finish by writing update conditions. What would move likely to very likely? What would lower it? What would overturn the whole explanation? If those conditions cannot be written, the event may still be too vague to evaluate.
The same probability can produce different actions. A 20% event may justify preparation when the potential loss is severe. An 80% event may not justify major spending when the impact is small and easy to reverse. Probability is only one input. The decision also depends on loss, action cost, reversibility, and risk tolerance. Legal, procurement, and executive teams may use different thresholds. The analyst explains probability and impact. The decision maker chooses the action threshold. Judgment can fail in two directions, and the costs are rarely equal. A false positive labels a safe supplier as high risk. It can destroy an opportunity, damage a relationship, and consume due diligence resources. A false negative misses a real risk and may lead to breach, compliance exposure, project interruption, or reputation loss. Screenshot verification has the same issue. Rejecting a genuine emergency notice may delay response. Accepting a fabricated notice may create panic. The task context determines how much evidence is required before publication or action. When time is limited, what evidence should we seek next? Not necessarily the easiest evidence, and not necessarily the most prestigious source. The best next item is the one most likely to change probability, confidence, or action. A 10th article repeating the same announcement has low marginal value. A customer-side confirmation, enforcement record, or reliable baseline may change the decision directly. Information value is incremental. A respected historical report can still be low priority if it does not affect the 6-month question. Stop when the expected judgment change is smaller than the cost and time required to obtain the evidence. Every probability change traces to a change in evidence. Each version records the date, event definition, probability range, analytic confidence, strongest support, main counter evidence, and largest gap. It also states whether the judgment rose, fell, or remained stable. An enforcement update may raise risk. Confirmation that hiring moved to another channel may lower it. Over time, compare forecasts with outcomes. That calibration history shows where the team tends to become overconfident and which signals repeatedly fail to predict the event. Return to the company case. Hiring declined, 2 lawsuits appeared, and an executive left. Those facts support rising risk. Continued partnership announcements and remaining open roles weaken the strongest deterioration narrative. Critical gaps remain. Customer contract changes, cash position, and actual delivery performance are not public. Alternative explanations include business restructuring, recruiting channel changes, and ordinary turnover. The event is not the company has problems. The event is specific, significant delivery pressure during the next 6 months. With the current evidence, we can place the event in the likely range, approximately 60 to 80% under the team lexicon. Why not very likely? The lawsuits, executive change, and hiring decline point in a similar direction, but customer, cash, and delivery data are still critical gaps. Analytic confidence is therefore moderate. A useful statement is, we assess that significant delivery pressure is likely to rise over the next 6 months, with moderate analytic confidence. Multiple public risk signals align, but independent customer and delivery data are unavailable. That judgment may support stronger contractual protections and more verification. It does not establish that the company has already breached a contract. Likely does not automatically mean stop the relationship. For a small trial, the buyer may continue with staged payments and stronger acceptance controls. For a long exclusive contract, the same judgment may trigger enhanced due diligence or delay. For a critical supplier, even a lower probability could justify a contingency plan. The report can use conditional language. If the business cannot tolerate 2 consecutive delivery failures, stronger payment protection is a lower cost control. The analyst informs the choice without pretending to make the commercial decision. The company is very likely to have problems. Leaves the event, time horizon, and meaning of problems undefined. We have 80% confidence creates another error. Does the event have an 80% probability? or is the analyst highly confident in some different estimate? Correct the statement by naming the event and period, then add probability, confidence, evidence, and limitations. High, moderate, and low confidence also need reasons. They are not self-awarded grades. The judgment card begins with the subject, event, and time horizon. It records the probability term, range, and whether the estimate rose or fell from the previous version. Next, write analytic confidence and one sentence explaining it. Then record the strongest support, counter evidence, and largest gap. Add the decision threshold, false positive and false negative costs, monitoring trigger and review date. Do not leave probability and confidence as empty drop-down choices. Another analyst should be able to see why each was selected and what evidence would change it. Choose one future event, such as whether a location will reopen within 3 months or whether a company will experience delivery pressure within 6 months. Write event probability and analytic confidence separately. Add 2 supporting items, 1 counter-evidence item, and 1 critical gap. Then write the action threshold, both error costs, and evidence that would raise, lower, or overturn the judgment. The completed card should let another student identify the most valuable next evidence and the condition that would trigger action. In the next lesson, we turn this calibrated estimate into a formal product by separating facts, inferences, judgments, recommendations, and conclusion boundaries.